Okay, now I will explain my code here. In this week, I'm responsible for creating a new method to generate topological sorts. The class I created here is sortable digraph. Um, Here I inherit from the versatile digraph, but I didn't assign any private attributes. Uh, the only thing I do is inherit from the superclass. So here I skip this constructor. Otherwise, it will raise the code analysis. The code analysis will raise an error about useless declaration. And I define the top sort method to generate a topological sort of a graph. Firstly, I define a dictionary to record the in degree of each node, and I iterate for each node to to find its in degree. Here I use this self-integrate method, which is the method from the superclass. I'm sorry, from the superclass. Here I use try except to handle this because um, if it if a node if a node has no integrate, if the integrate of a node is zero, then this method will raise a key error. So if a key error is raised, it means this node if it means this node has no integrate. This the integrate of this node is zero. So I use try except to handle this. And then after I define this count dictionary, I will also choose some initial valid nodes. The initial valid nodes has the integrate of zero. So I use list comprehension to implement this. That I use this stack to implement a queue instead of stack. So the property of queue is first in, first out. So I can pop the first element instead of the last using the pop left method here. And I initialize the results and empty list to store the elements, which is the final result of topological sort. And I use while loop to iterate all the nodes in the graph. Firstly, I will pop the first element in this initial nodes and add it into the result. After I pop the first element, it means I remove it from the directed graph. After it is removed, I need also to remove all the edges leading from this remove node. Since it's in degree zero, there is no edge leading to it. So I will use this self successor to check whether there are successors of this remove node. If a key error is raised, it means there is no successor of this remove node. Then the successor list will be an empty list. If there are successors of this remove node, it means that all the edges leading from this remove node leading to its successors will also be removed from the graph. And after all those edges are removed, I also need to update this count dictionary. I also update the in degree of each successors by subtracting one from them. And after I use this for loop to subtract one from the nodes which is the successor of this remove node, I will also find After updating uh, whether there are nodes has the in degree of zero now. If for each node has the in degree of zero now, and we also append them to this initial nodes, which means it can be removed from the graph now. It has no dependencies. And after I use a while loop. After I iterate all the nodes, I will return the result, which is exact the topological sort. Okay, now let me execute. I add a nodes and edges using the method from the superclass, and I plot the directed graph. Okay, so this is a graph. It has the same structure with the with this one with the core site. So here I didn't do other things like remove the age weight, something like that, because it is not necessary. Okay, we can see it has the same structure with the picture shown in the core site, and I will generate a top sort. It return this list. Let me illustrate it. So for this one, in the first, it has shirt because shirt has no dependencies, and I will remove this node as well as other edges. After updating that, we can see this tie, this pant, this sock, and this vest also has no dependencies. So the next is socks. It has no dependencies. And the next one is tie. It has no dependencies. Next one is vest. It has no dependencies. And next one must be pants because it is the only node now has no dependencies. So the next one is pants. And the next one will be either belt or shoes. So here is the belt, and here is the shoes, and the last one is jacket. So the topological sort is not unique, but here this algorithm generates a valid one. Okay, so that's my assignment for this week.